Hey kiddos, I hope you had a good weekend. We are 10 days away from Christmas break, so we got 2 more full weeks of school, and then it's finally Christmas season. Super excited. But we do have a lot to get through in these next 10 days. We are going to do our last unit of the semester. So our next unit is sequences and series. So we're going to start with sequences and with series just in that order. This unit shouldn't be too bad. There are just a lot of formulas, so make sure you are taking good notes, organizing your notes so you don't get confused. Make sure you're writing learning targets or titles up at the top so you know what is what. As well as please make sure you are staying on top of your assignments, especially with only being 2 weeks left of school and semester exams right after we come back from Christmas break. It's going to be crucial that you are not behind on assignments and you're ready for our semester review come the first week of January. So please make sure you're staying on top of things, you're doing your assignments when you're supposed to, and you're asking questions if you have them. So what we are doing today is we're going to do a couple, we're going to finish one learning target and we're going to start another learning target because the second one has a lot of parts, so we're not going to do them all in one day. But for today, our learning target is I can find the nth term of a sequence. So starting off with some basic vocab, a sequence. A sequence is a list of numbers in a special order. So that's the simplest way to put it. Sequences, they also follow certain rules. So for example, going up by 3 every time or being multiplied by 2 every time. We'll be dealing with both addition and multiplication throughout the course of this unit. So that's why I did those 2 examples. So for instance, if we are given the following sequence, 3, 5, 7, 9, ... So this is called your first term or your first element, either or. And another way that you might see that written is this also might be called A with a subscript of 1. So if you've never heard the term subscript before, a subscript is just a little number in the bottom right-hand corner of a variable. We're used to exponents that are up here, a subscript's down here. These might sound familiar from science class. So like this one would be your second element, your second term. This one would be, we'll say this is your third term. So this would be A to the third, or you might have different letters there, but typically we see A. And then these ... dots, these are called, typically you see them as ellipses in English. This lets you know that the sequence goes on forever. So I don't think that should be too new information. If it is, that's completely fine. This is what we're going to be working with the next couple of days. So if we want to find the nth term of a given sequence, so we're going to be given a formula of a sequence. So if I tell you I want you to find the terms a to the n equals 3n minus 1, and I want you to find the first 3 terms. So this is something that you all have been doing for years. We did it a whole bunch of times in previous units where if you have an x and you want to find a y, you're going to plug in your x. So you're going to do the same thing here. If I want to find my first term, this is going to be a1 is going to equal 3 times 1 minus 1, which is going to equal 3 minus 1 is 2. Same thing, a2 equals 3 times 2 minus 1, it's going to equal 5. A3 equals 3 times 3 minus 1, which is going to equal 8. So the first 3 terms would be 2, 5, 8, so on and so forth. So on and so forth. Same thing is if I wanted to find if I wanted to find A15 from that sequence, I'm going to do the same exact thing. A to the 15th is going to equal 3 times 15 minus 1, which is going to equal 44. You could do that for, if you want to find the 1,322nd term. This is exactly how you would do that. You all know how to find values this way. It might not have been in the terms of sequences, but we've done it tons of times in XY tables and stuff like that. So using this idea, this is what we're going to be focusing on throughout this unit, is finding terms and finding sums and all that jazz. So this learning target, it is one of our learning targets, but we're going to be doing it continuously throughout the unit. So it's not going to be something that we have a specific practice on today for this learning target, but we're going to be practicing it in another learning target, if that makes sense. Okay, so after we have that, we're going to move on to identifying arithmetic sequences. Okay, so this is one of 4 parts of a big learning target. I will post a learning target in Classroom, but it's too much to write out for our notes. So for arithmetic sequences, are sequences whose rule, quote unquote rule, involves addition. Addition being the key word. There is no subtraction for arithmetic sequences. We are always doing addition. So for example, if we are given the sequence 9, 10, 1, ... And if I want to be able to tell if this is an arithmetic sequence, I need to see if it has a common difference. So a common difference is the difference between terms 1 to 2, 2 to 3, 3 to 4, so on and so forth. So in order to be an arithmetic sequence, you have to have a common difference between each of your terms. So there's a couple different ways to think about this. So if I want to know how am I getting from 19 to 10, I know your first instinct is probably like, oh, well, you're subtracting 9. But remember, arithmetic, we do not subtract. We have to think of it in terms of addition. So what do I need to add? 19 plus what is going to give me 10? And that's going to give me a negative 9. And same thing here. So that's the ratio for, or the common difference for this one. If this is an arithmetic sequence, this is going to have the same common difference. So to go from 10 to 1, I'm also going to be adding negative 9. Or if that's kind of hard for you to think about, another way that you can find the common difference is D, which stands for common difference, is equal to A2 minus A3. So A2 minus A3, my second term is 10. I'm sorry, this should be A1. My apologies, this should be A1. 10 minus 19 is going to give me that negative 9. Or you can think about it, it's equal to A3 minus A2, which is going to be 1 minus 10, which also equals negative 9. So the common difference is found, so I'm going to abbreviate it CD, is found by subtracting any term by the term before it. So no matter how many terms you go down the sequence, they're all going to have the same common difference of negative 9. So if we were given the sequence, that's a horrible E, 3, 7, 11, dot, 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 and we're asked to find the common difference. So we'll do it both ways. To go from 3 to 7, that's going to be plus 4. To go from 7 to 11, that's going to be plus 4. Or if we want to do it the other way, we're going to have D equals A2 minus A1, so 7 minus 3 equals 4. Or D equals 11 minus 7, which also equals 4. So our common difference is going to be 4. So if you have a common difference, if you can find something that is, if you add it consistently from term to term to term, and you're ending up at the same, if you're ending up at the next term by adding by the same thing, that means you're going to have an arithmetic sequence. So for instance, if I had like 5, 6, 7, 8, I'm adding by 1 every single time. So that's going to give me an arithmetic sequence. If I had 3, 6, 7, 12, okay, this one I'm adding by 3, this one I'm adding by 1, and this one I'm adding by 5. These do not have a common difference, so this would not be an example of an arithmetic sequence. This is not a sequence because it does not have a set rule that it's going by. Okay, so there will be a little bit of practice with this in Delta Math for you to do today. And let's see, what else do we have today? Get a piece of paper. All right. And then also we're going to learn how to find the nth term given an arithmetic sequence. So if I am given the sequence of negative 26, negative 37, negative 48, so on and so forth, and I want to find the 94th term. So the first thing you're going to start out by doing is finding your common difference. So I want to find my common difference. So I'm going to do negative 37 minus negative 26. Type that in my calculator. That's going to give me a negative 11. Or if I do negative 48 minus negative 37, that's also going to give me a negative 11. I could check it this way as well. Negative 26 plus negative 11. Yep. And same thing here. So my common difference is going to be negative 11. I'm adding negative 11 from term to term in order to find my next element in my sequence. So once I have my common difference of 11, I am then ready to use my formula for arithmetic sequences. So this is, for arithmetic sequences, our formula for finding missing terms is a to the n, or an equals a1 plus n minus 1 times d. Okay, where a to the first is your first term. N is the term you're trying to find. So I'll put a question mark there, the term we're trying to find. D is your common difference. And then this little n is also going to be the term that you're trying to find. So after I have my common difference, it's just a matter of plugging things into this formula. So I want to find the 94th term. So a to the subscript of 94 is going to be equal to a1. So my first term in my sequence, which is negative 26. And then we're going to have plus parentheses n minus 1. So n is the term I'm trying to find, 94 minus 1 times my difference. My difference is going to be negative 11. So this is going to give me negative 26 plus 93 times negative 11. Meaning that the 94th term of this is negative 1,049. So you could, in theory, if you know your common difference is negative 11, you can add negative 11 94 times until you get this answer. But we use this formula so that way we do not have to do that, because that sounds tedious and torturous and it's very easy to miscalculate while using the calculator. So this formula is a real big lifesaver for allowing us not to have to hit plus negative 11 94 times. So for another example, if I have 8, 24, and 40, and I want to find the 98th term. So first things first, my common difference. So that's going to be 24 minus 8, which is going to give me 16. And 40 minus 24 is also going to give me 16. So I'm good to go there. This is an arithmetic sequence. And now I'm good to use my formula. So a to the n, so it's going to be a to the subscript of 98 equals my first term, so 8, plus the term I'm trying to solve for, 98 minus 1, times my common difference of 16. So this is going to give me 8 plus 97 and 16. So that's going to give me 8 plus, 97 times 16 is going to give me 1,552. You're going to add those together and you're going to get 1,560. So the 98th term of this sequence is 1,560. So I recommend starting a formula sheet. This is one of just many formulas that we're going to be using this semester, or not this semester, this unit. So if you're someone that likes to stay super organized, which I hope we all are, start making a formula sheet to keep at the front of your binder and make this your number one formula for finding the nth term, giving an arithmetic sequence. So that's all I have for you today. Tomorrow we're going to work on writing equations from sequences. So if you hop on in, if you look under this video in Delta Math, you'll have a few practice problems to do today. I will be here as always to answer questions. So please make sure you are asking them if you have them. Don't just accept struggling. All of you are capable of doing this, but we all might need a little bit more help sometimes, which is totally fine. So please make sure you are asking for help if you need it. I cannot express that enough. As well as I highly encourage you to watch these videos during our scheduled class time for the day. I know some of us like to work at night, which I understand, but I'm not there to help you when you're working at home at 10 o'clock at night. So please make sure that you are planning accordingly to make sure you're getting the help that you need. Otherwise, if I don't talk to you again today, I hope you have a great day, and I'll see you tomorrow on our Google Meets. Bye.